Hello everyone, myself Sindhashri. So today I'm going to discuss about wind power. As everyone knows, wind power means it is a generated electricity generated by using a wind, which is a renewable sources. At first, let me give some introduction. Introduction to wind power. Wind power is a renewable energy sources that uses wind turbines to generate electricity. Wind turbines are large structures that have blades that spin in the wind, which turns a generator to produce electricity. So usually electricity is generated using a windmills, which are located in high hill stations, which contains turbines and a wheel. Through these turbines and wheel, by using wind we generate electricity. Next, let me discuss about intermittency and variability. The first is unpredictability, and next is intermittency challenges, and next is backup power, and next is energy storage solutions. Wind power is an intermittent energy sources. It means that wind speeds are highly variable and can change rapidly, making it difficult to predict when electricity will be generated. Intermittency challenges. Intermittency poses a challenge to a grid stability, especially in locations where wind power constitutes a large portion of the grid's energy supply. Next is a backup power. To address intermittency, operations need to have a backup power sources available to ensure a continuous supply of electricity when wind speeds are low. Next is energy storage solutions. This involves using batteries, pumped hydros, or other technologies to produce electricity during the periods of high wind speed and releases it when we are needed. That when the electricity is low. I mean when wind power is low, when there is no wind power. At next, let me discuss about transmission and grid integration challenges. Transmission infrastructure, and next is grid capacity, and next is grid modernization. Wind frames often need to be located in remote areas where wind resources are abundant. This means how long distance transmission lines are required to transport the electricity to urban areas. This means where wind frames often need to be located in such a area where wind resources are more. Placing windmills in the area such that where there is wind is less, then it is of no use and the cost is also simply wasted. So we have to place the windmills in such a place where the wind is more abundant. Then grid capacity. Integrating a large amount of wind power into our existing grid can overload the grid's capacity, leading to voltage fluctuations and power outages. We should also take care about the grid capacities. That means when we are integrating large amount of wind power into a single grid, which leads to many voltage fluctuations and also the failure of the windmills, that grids. Next is grid modernization. Upgrading the existing grid infrastructures to accommodate more wind power is crucial for smooth integrations and reliable operations. Next challenge is we have to update the present grid, which with the infrastructure and accommodated more wind power to accommodate more wind power. Next, let me discuss about environmental wildlife impacts. First is bird and bat mortality. Next is habit fragmentation. And next is noise pollution. The first is bird and bat mortality. Wind turbines can pose a risk to the birds and bats, especially when they are located in the areas with high avian or bat populations. So usually windmills normally used to generate electricity when the windmills are located in high hill stations, when birds are flying, or where the place where bats and birds are high. They may cause some shock or some electric shocks to birds. So it is one impact. Next is habitat fragmentation. Construction of wind farms can fragment habitats, which can affect wildlife populations. So, to construct a wind farms, we need a large amount of area. So, so that some of the habitat who are staying in that area will have to be fragment. So, this affects for the wildlife population. Next is noise pollution. The sound produced by wind turbines can be disruptive to wind life and particularly birds. The turning sound what were produced by windmills will be effective, or it will be like a noise pollution for birds and many some other wildlife animals. Next, let me discuss about land use and visual impacts. So, land requirements, visual aesthetics, community concerns. In land requirements, wind farms require significant amount of land, which can impact agricultural land use and other land-based activities. Next is visual aesthetics. The presence of large wind turbines can be visually disruptive, particularly in the areas with sunset landscapes. Next is community concerns. Local communities may have concerns about the visual impact of wind farms on their neighborhoods and property values. Next, let me discuss about cost and economic viability. Initial cost. There are three ways. Three parts of cost. That is initial cost, operating cost, and intermittency cost. Initial cost. Wind turbines are expensive to manufacture and install, requiring substantial capital investment, and operating costs such as maintenance and repairs can be significant over the lifespan of the wind turbine. Intermittency cost. Intermittency requires backup power and energy storage, which add to the overall cost of the wind power. Now let me discuss about the maintenance reliability uses. At first is turbine maintenance. Next is blade inspections. Then gearbox and generator. Weather related challenges. Turbine maintenance. Wind turbines are complex machines that require regular maintenance to ensure optimal performance and reliability. Blade inspection. Wind turbines blades are prone to the damage from lightning strike, bright strike and other factors. Gearbox and generator are critical component of a wind turbines and require periodic maintenance and replacement. Weather related challenges. Extreme weather events such as hurricanes and tornadoes can damage the wind turbines and disrupt operations. At last, let me conclude and give conclusions on the future work. First is growing importance. Wind power is expected to play an increasingly important role in the transactions to clean energy future. Next is technological advancement. Continual research and development are leading to more efficient and reliable turbines. Next is cost reduction. The cost of wind power is declining, making it more competitive with traditional fossil fuels. Then next is synergy with solar. Combining wind and solar power can create an resilient energy system. So these are the topics what I have discussed so far. Thank you.